In the modern world, steel pipes form an underground network to deliver necessities like drinking water or fuel. These pipes are often spirally welded and can be made in any size. In fact, longer pipe means fewer joints and less work to install them underground. Spirally welded pipes can be short, or they can go on and on. The potential length is limitless because, unlike other kinds of pipes, spiral pipes don't have to conform to the size of a forming roll or the dimensions of a steel plate. They can spiral weld these coils of steel sheets endlessly. But first, they have to take the kink out of the coiled steel. A machine unwinds it and pushes it between rollers to completely flatten it. A fixed arm then presses the steel against rollers to round it to a precise diameter. And an automated system welds the formed pipe from the inside. A barely visible mantle of powdered flux protects the welding process. Copper-coated steel wire acts as both an electrode for the welding process and as filler material. With the inside weld complete, a second welder device works on the outside of the pipe to give it a double welded seam. A plasma torch cuts the pipe to length cleanly by melting it. In this case, they're making a water pipe that's 6 feet in diameter and 50 feet in length. The pipe then rolls over to the next station. Here, a worker grinds both ends of the pipe to improve the profile. Then it's over to a die. It stretches one end of the pipe to create a slight flare or bell. This will allow it to be connected to the narrower end of another pipe, forming what's known as a lap joint. Next, they cap the ends of the pipe and pump in water to a highly pressurized state. They look for leaks in the weld and confirm that it's watertight. Another worker installs rubber dams at both ends of the pipe. A cement fixture then flows into a long applicator with a nozzle. The nozzle applies the cement to the pipe's inner wall as the pipe spins and generates a centrifugal effect that's 70 times the force of gravity. This causes the cement to be distributed uniformly. The rubber dams contain the cement during this process. The spinning displaces water in the cement, and a blower forces that water out of the pipe. Next, a worker drapes plastic onto both ends of the pipe. He tacks it with magnets and then secures it tightly with an elastic cord. He pumps hot steam into the pipe. Over a period of 18 hours, the steam cures the cement. It's a slow cure for better structural integrity. For our camera, they open one end of the pipe for an inside look at the steaming action. 18 hours later, they remove the rubber dams. The spiral welded pipe now has a tough protective inner liner. Next, the pipe moves into a blast chamber where fine steel shot bombards the outside of the pipe to clean it thoroughly. This prepares it for the next step. A sprayer applies a liquid adhesive. Over the adhesive, they wrap a polyethylene-backed tape. They apply a total of 3 layers of tape. The first one provides corrosion protection to the spirally welded steel. The other 2 layers protect the first. They give the spirally welded pipe a tough outer skin. The 3 tapes are color-coded. This will allow the depth of any damage to be quickly assessed on site. They produce approximately 15 spirally welded water pipes per 8-hour shift at this factory. They should last for a century underground. If you have any comments about the show, or you'd like to suggest topics for future